Please bow your heads and let us pray. Dear Jesus, please show me how to spend this day sharing your love in every way. Help me to be kind to everyone, to play and love and have lots of fun, shining your light and giving your grace, sharing your joy with a smile on my face. Angel of God, my guardian dear, to whom God's love commits me here. Ever this day be at my side, to light and guard, to rule and guide. Amen.
Good morning to everyone. Today we will learn more about metalworking. I am Antonina M. Del Rosario together with Mr. John Ivan de la Cruz and Miss Lyka-Jane Domingo, and we are the Group 5. Let us start this discussion. The first topic that we are going to talk about is the binary shielding gas blends. Do you have any idea what binary shielding gas blends are? Shielding gases are inert or semi-inert gases that are commonly used in several welding processes, most notably gas metal arc welding and gas tungsten arc welding. The primary purpose of shielding gas is to protect the molten weld pool against elements in the atmosphere such as nitrogen and hydrogen. Binary means consisting of two things or parts, so it means that binary shielding gas is a two-part shielding gas blends, which is the most common, and they are typically made up of either argon plus helium, argon plus carbon dioxide, or argon plus oxygen. Let us differentiate between these three binary blends. Argon plus helium is the first binary gas blends that we are going to talk about. Binary argon plus helium blends can be used to weld nickel-based alloys and aluminum. The metal transfer mode employed is either axial spray transfer or pulse spray transfer. The addition of helium increases paddle fluidity and results in a flatter bead shape. Helium promotes faster travel and reduces the finger-like projections seen with the pure argon in aluminum GMAW. Helium has also been linked to a reduction in the appearance of hydrogen pores in welds made with aluminum and magnesium fillers. The argon component promotes cleaning action on aluminum and provides excellent arc starting. Here are the common argon plus helium blends. 75% argon plus 25% helium. This binary blend is frequently applied to improve the penetration profile for aluminum, copper, and nickel applications. The paddle is more fluid than 100% argon. Next is 75% helium plus 25% argon. The higher helium content increases the thermal conductivity and paddle fluidity. The penetration profile is broad and exhibits excellent sidewall penetration. Why is argon and helium used in welding? Argon and helium in gas blends are useful for welding. The higher heat and broader penetration pattern of the helium plus argon mixtures will generally help to minimize gas entrapment and lower porosity levels in the completed weld. The second blend is the argon plus carbon dioxide. The most commonly found binary gas blends are those used for carbon steel GMAW welding. All four traditional modes of GMAW metal transfer are used with argon plus carbon dioxide binary blends. They have also enjoyed success in pulse GMAW applications on stainless steel where the carbon dioxide does not exceed 4%. Axial spray transfer requires carbon dioxide contents less than 18%. Argon plus carbon dioxide combinations are preferred where mill scales is an unavoidable welding condition. As the carbon dioxide percentage increases, so does the tendency to increase heat input and risk burn-through. Argon plus carbon dioxide blends up to 18% carbon dioxide support pulse spray transfer. Short-circuiting transfer is a low-heat input mode of metal transfer that can use argon plus carbon dioxide combinations optimally. These modes benefit from carbon dioxide levels greater than or equal to 20%. Use caution with higher levels of argon with short-circuit metal transfer. Here are the common short-circuiting transfer shielding gas blends. 75% argon plus 25% carbon dioxide. It reduces sputter and improves weld bead appearance on carbon steel application. Next is 80% argon plus 20% carbon dioxide. This is another popular blend which further reduces sputter and enhances weld bead appearance on carbon. Next is the common axial spray transfer shielding gas blends. 98% argon plus 2% carbon dioxide. For axial or pulse spray with stainless steel electrodes and carbon steel electrodes. This blend has seen repeated success on high-speed sheet metal application. There is excellent paddle fluidity and fast travel speeds associated with these shielding gas blends. Next is 95% argon plus 5% carbon dioxide. For pulse spray with carbon steel electrodes, the addition of 5% carbon dioxide provides for additional paddle fluidity and it lends itself to heavier fabrication blends with 2% carbon dioxide. The last blend is the argon plus oxygen. Argon-oxygen blends attain axial spray transfer at lower currents than argon and carbon dioxide blends. The droplet sizes are smaller and the weld pour is more fluid. The use of argon plus oxygen has historically been associated with high travel speed welding on thin materials. Both stainless steels and carbon steel benefit from the use of argon plus oxygen blends. 99% of argon plus 1% of oxygen is used for stainless steel applications. The use of oxygen as an arc stabilizer enhances the fine droplet transfer and maintains the paddle fluidity for gas blends. Stainless steel weld will appear gray because of the oxidizing effect of the weld pool. 99% of argon plus 2% of oxygen is used as shielding gas for either carbon or stainless steel application. The earliest use of argon-oxygen blends for axial spray transfer on carbon steel employed 2% oxygen level. It is typically applied to the applications that require high traverse speed on sheet metal. Applied with either axial spray or pulse spray transfer mode, stainless deposits are dull gray in appearance. This blend is often used when superior mechanical properties are required from low-alloy carbon steel electrodes.
What is ternary shielding gas blend? So, ano nga ba ang ternary shielding gas blend? So, three-part shielding gas blends continue to be popular for carbon steel, stainless steel, and in restricted cases, nickel alloy. So, for short-circuiting transfer on carbon steel, the additional of 40% helium to argon and carbon dioxide is a third component to be shielding gas blend provides a broader penetration profile. So, ibig sabihin, sa tulong ng 40% na helium, mas nagiging mas malawak o mas nagiging mas matibay yung ginagawa nating pagwe-weld. So, helium provides greater thermal conductivity for short-circuiting. Transfer application can on carbon steel and stainless steel base material. The broader penetration profile and increased sidewall fusion reduce the tendency for incomplete fusion. So, ibig sabihin, habang mas lumalahawak o mas nagiging maganda yung quality ng welding, syempre, mas liliit yung tendency nga ng mga incomplete fusion. So, for stainless steel application, three-part mixes are quite common. Helium addition of 55% to 90% are added to argon and 2.5% carbon dioxide for short-circuiting transfer. So, kapag pala sa stainless steel naman ginagamit, nag-i-exceed o mas tumataas ng hanggang 55% hanggang 90%. They are favored for reducing spatter, improving paddle fluidity, and for providing a flatter weld bead shape. So, ibig sabihin, mas nagiging maganda nga dahil doon sa pagdadagdag nga ng helium at saka nung carbon dioxide. So, ternary shielding gas mixture. Argon, oxygen, carbon dioxide mixture contains these three components have been termed as universal mixture due to their ability to operate using short circuit, globular, spray, false, and high density type transfer characteristic. So ito palang ternary shielding gas mixture ay pwede siyang gamitin sa kahit na alin sa mga ito, sa short circuiting, sa globular, spray, false, and high density type ng pag-transfer. So several triple mixes are available and their application will depend on the desired metal transfer mechanism and optimization of the arc characteristic. argon is 5 to 10% and carbon dioxide is 1 to 3%. This ternary mixture range has gained popularity in the US over the last several years. The chief advantage is its versatility to weld carbon steel, low alloy steel, and stainless steel of thickness, utilizing whatever metal transfer type applicable. So ibig sabihin, yun nga, naging popular siya sa US dahil nga sobrang lawak nung napaggagamitan sa kanya, lalo na sa mga maninipis na bakal, kagaya nga ng mga nabanggit na carbon steel, alloy, at saka stainless steel. So stainless steel welding should be limited to spray arc only due to the stiffness of the paddle at low current level. Carbon pick-up on stainless steel should also be considered in some instances. On carbon and low alloy steel, this mixture produce good welding characteristic and mechanical properties. So sa carbon at saka sa alloy pala, dahil sa ternary gas blend ay nagkakaroon tayo ng mas magandang quality ng welding. So in this gauge material, the oxygen's constituent assist the arc stability at very low current level from 30 to 60 amperes, so permitting the arc to be kept short and controllable. This helps minimize from burn through and distortion by lowering the total heat input into the weld zone. So ibig sabihin, dahil nga dun sa 30% to 60 amperes, mas sigiging kontrolado nga natin yung init na kung saan naiiwasan natin yung pagkasunog ng bakal o kaya naman yung pagkabaluktot.
Hello, good morning again. I'm Domingo Lyka-Jane, and let's continue discussing GMAW or Gas Metal ARC Welding Shielding Gas Selection Guide. At the end of the video, the viewer will be able to choose the best shielding gas, discuss the gas selection guide, and lastly, demonstrate how shielding gas selection guide perform. Now let's talk about shielding gas. As all we know, this is an inert or semi-inert gases that are commonly used in welding process to protect the weld area from oxygen and water vapor. In using wrong shielding gas or gas flow will affect the weld quality, cost, and productivity, as these used to protect the mold in full from outside contamination. So it's critical to choose the right gas for job. There's several factors to determine the right shielding gas for GMAW process, including the type of the materials, filter metal, and weld transfer mode. And the first one is the material type. This is the biggest factor to consider for the application. For instance, a carbon steel and aluminum have very different characteristics, and therefore it requires different shielding gases to achieve the best result. Secondly, the filter metal type. In this type of the filter metal matches the base material, so understanding the materials give us an idea about the best gas for filter metal. The third one is the welding transfer mode. This mode is essential variable primarily associated with GMAW process. It also have three different types. The first one is the deep, the second is the globular, and lastly, the spray transfer. So there are gases pair that is suitable for different base materials. The first one is the aluminum. In using these materials, ensure that the argon is 100%. Our argon and helium when mixed together works well if requiring deeper penetration or a faster travel speed. This used to have the oxygen tends to run hot and add layer of oxidations. The second one is the mild steel. We can pair these materials with a variety of shielding gas option including 100% of carbon dioxide or argon mix because it helps the materials to become thicker, and if we add oxygen to argon gas can help with penetration. The third one is the carbon steel. These materials pair well with 100% carbon dioxide and argon mix. The fourth one is the low alloy steel. 90% of argon and 2% of oxygen gas mix is suitable for these materials. Lastly is the stainless steel. Argon mixed with 2 to 5% of carbon dioxide when it requires extra low carbon content in weld. Use argon with 1 to 2% of oxygen. So after knowing which gases are pair best with different materials, let's talk about on how optimizing shielding gas performance. Choosing the right shielding gas is the first step towards success. Optimizing performance, saving time and money required us to aware of the best practices that can help us to conserve shielding gas and promote proper coverage of weld pool. So there are 6 tips that I will discuss on this video. The first one is the flow rate. The proper flow rate depends on many factors including the travel speed and the amount of mill scale on base materials. A turbulent gas flow during welding typically means flow rate. Measured in cubic feet per hour is too high, and this can cause problems such as porosity. If any welding parameter change, this can affect the gas flow. For example, increasing the wire feed speed also increase either the size of the weld profile or the travel speed, which means you may need a higher gas flow rate to ensure the proper coverage. The second one is the consumables. The GMAW gun consumable consisting of a diffuser, contact tip, and the nozzle play a crucial role in ensuring that the weld pool is properly protected from the atmosphere. If the nozzle is too narrow for the application or if the diffuser becomes clogged with spatter, we need to choose consumables that resist splatter build up and provide a wide enough nozzle bore to ensure adequate gas coverage. And be sure that the contact tip resist is correct. The third one is the gas free flow. Running a shielding gas for a few seconds before striking the ARC can help ensure there is adequate coverage. Using a gas free flow can be especially helpful when welding deep grooves or bevel that require a longer wire stick out. This free flow fills the joint with gas before starting, may allow us to turn down the gas flow rate, thereby conserving gas and reducing costs. When using a black gas system, conduct proper maintenance to help optimize performance. Every connection point in the system is possible source of a gas leak, so monitoring all connections to make sure they're right. Otherwise, you may be losing some of the shielding gas that we think is getting to the weld. The fifth one is the gas regulator. Precise mixing is important for weld protection, so we need to ensure that the right regulator based on the gas mix we're using, and use of improper regulator for a gas mix can result in safety concerns. Checking regulators frequently will help us to ensure they're working properly. The last one is the gun updates. If we are using an out-of-date gun, we need to look into updates model that offer benefits such as the smaller interior diameter and an isolation gas hose light, which allows us to use lower gas flow rate and help prevent turbulence into the weld pool while conserving gases. So after gaining a lot of knowledge in this video, I hope that it can help you in your future endeavors. Thank you and God bless us all.